let's graph the function, the exponential function 1 plus 3 to the x. What we want to do here is to graph the specific function using a table of values that I have already created here for you that give us the different points of that we will connect in order to get the curve for this function. Few things that we can get from the rule is that the horizontal asymptote of the exponential function, remember every exponential function has a horizontal asymptote, is going to be y equals to 1, okay? And this is given by the constant of the exponential function. So number 1 right here gives us the horizontal asymptote. So we know a few things. We know a total of 5 points. We know the horizontal asymptote. We can graph this function. Now, the reason of graphing this function right here is to actually take now the points of this function and get the inverse of the function and graph the inverse of the function without actually going through the steps of finding what the inverse is. This is something that we will do in a later presentation. So in order to get the inverse of the function g of x, that is nothing else than f inverse of x, what we should do right here is do the following thing. First of all, the vertical asymptote is going to be nothing else than x equals to 1. So that's the first thing that we do. Why is that? Because all the points, all the information for the initial exponential function will translate into symmetric points and lines on the inverse function. That's the first thing. And the second thing is that we take each one of these points. So 1 and 1/9 is nothing else than 10/9. So I'm just rewriting this as a fraction, comma -2. So what I do is I rearrange the x and the y intercepts here in order to get the points of the inverse function. This is going to be 4/3, comma -1. This is going to be the point 2, 0. This is going to be the point 4, 1. And this will give me the point 10, 2. I just changed the y-intercepts to become the x-intercepts and the opposite. So now, if I connect these points that I have right here, these points will give me the curve that is nothing else than the inverse of the initial function. So let's do both at Desmos first. I have the points, the initial points that we show together right here, these points right here, the points that correspond to the f of x. And what I get are the following points, the -2, 10/9, and so on. It is clear that if I connect those points, I'm going to get an exponential function. The curve is that of an exponential function. If I want to also graph the intercept, the horizontal asymptote, this is going to be that. If I connect these points, then what I get is 1 plus 3 to the x. And of course the points are going to be connected, the ones that we already found in our graph right here. And this is our exponential function. This is the f of x. Now, what I'm going to do is I will create a similar, the inverse function of that by continue and creating here at Desmos the points that are the opposite points of my function. So instead of x, I will have the y coordinate and the opposite. So let me write the points down, and this is going to be 10/9, -2. That will be the first point, -2. You can see the point right here on your graph, and these points correspond to -2, 10/9. So you see that these points, they have interchanged coordinates. The next point that I'm going to graph is 4 over 3 comma negative 1, 4 over 3 comma, 4 over 3 comma negative 1. The next one is the 2 comma 0. So as you can see, the only thing that I do here is I interchange the x and the y coordinates, nothing else. And I will also graph the vertical asymptote, x equals to 1 this time. Now, if we look at our graph right here, you see the exponential function that I have already created, the f of x, and you see the points of the inverse. These are the points right here. And if I connect those points, then I'm going to get the inverse of the function. We may want to go further and connect those points, although you don't know how to find the rule of the function. I will just add that there so we can connect the points. And the graph that you get, if you connect the points that we found from the table, I remind you that the table is right here. These are the points that I connect. The graph that you get is the curve that you see, the purple curve that you see right here. And if you also graph the bisector of the first quadrant, y equals to x, you can definitely see right here that the two curves are symmetric around that. And each one of the points have a corresponding point on the initial function that is a point that has the x and the y coordinates flipped. Okay, now in a later presentation we are going to learn how to find from the initial function f of x, that is n1 plus 3 to the x, the corresponding inverse. Now we already discussed that the corresponding inverse is going to be a logarithmic function, and the logarithmic function that we will find is this. For now you don't want to do that. The only thing that you want to do is find the table of the points for the initial function, reverse them, change the horizontal asymptote to a vertical asymptote, and graph those points and connect them. And the answer that you will get is the purple line right here, that is the logarithm with base 3 of x minus 1.